Hello and welcome to all my Eliasmia students of Computer Science Department. This is a tutorial video regarding the topic recursion based question answer programming generally, which you will get in the year paper questions, which is a theory paper questions. Mostly recursion comes every year in the two form. One is a recursion based output question, 5 mark, and one is a 10 mark recursion question related to different methods and the recursive methods. Also, you have to write it by your own. As it is one of the old topic, we have already did similar kind of program in class 11. So I am directly going to the type of question related to it in ISC. We have already performed this type of question, so I think one time of revision will be good for you to move ahead for the ISC papers. We will solve two random year questions like 2011 over here, and then we will move forward to the question year number 2012. These are the two random questions I have picked up. We can solve any other question also other than that. And let's move forward the question answer solving. I will provide you the same way by writing it by my own and also help you to form other questions. Okay. So let's start with the first question that we will get over here, which is the year 2011 recursion based question. It is mentioned a class DECOCT has been defined to convert a decimal number into its octal equivalent form. Some of the members of the class are given below as class name as DECOCT, data member as instance variable, which is n, a decimal number. Oct is also an integer type of variable. We have member methods mentioning over here as DECOCT, which is a constructor, default constructor, mentioning as to initialize n as 0 and oct as 0 also. Next, the method void get num, which is having a argument passed as assign nn to n. Void DECOCT, which is similar the recursive function over here, dec_oct. Please do not get confused as the main class name is also DECOCT, and here also we are using a method DECOCT, which is actually dec_oct. So underscore is very important over here as it is exactly mentioned in the question. And as per the description, calculate the octal equivalent of n and stores it in the oct using a recursive technique. So this is the function where we are going to make the recursive form of it. And last but not the least, we are going to store the result in the variable oct over here. Void show is mentioned, which is display the original number, which is n, and call the function DECOCT and display its octal equivalent. It means that the recursive function we need to call it not in the main but in the void show. So whenever we are going to write the main, over there we are only going to call the getNum function and the void show function. We are not going to call the DECOCT_oct recursive function, because this is what we are going to call inside the void show. So let's start with the program. While begin with, I have created a BlueJ recursion project, and you can create one of the new one for your ISC. And as per mentioned in my question, my class name is DECOCT. So I am writing that. Okay, it's in the cap form. So I'm going to writing in DECOCT as exactly what is mentioned, and then create the class name. Opening the whole thing, we will clear out everything over here. We'll start with import java.util.star semicolon, enter as class dc oct, exactly whatever is mentioned, open curly brace. Two private member variables are mentioned. One is n, another is oct, which will store my result. Next, we will move forward to the, I think it is DECI. Okay, let's change it. You can just compile it, it will be changed automatically. So DECI oct, which is a default constructor, and as mentioned in the question, it will be initialized as 0. Next we have void get num function with an argument int nn, and it is mentioned that pass that value to n, which is my private data member. Now we are going to write the recursive function. Let me show you one trick. What I'm trying to do is that I am right now, instead of writing the recursive function, I'm giving it a gap and first writing the void show. This is because I want you people to write the easier part first. Okay, if each and every method of here will have some kind of marks allotted to it, so I don't want you people to get confused in the DCOC function while writing the recursion form of it. Clear out rest of everything till even the main part, and then we can clearly think what we need to write inside the recursive method, and we will write it. So as per the show, it need to show me the original value which is stored in n and the resultant value which is stored in oct. So what I'm going to write is that I'm going to write system.out.println the original number which is stored in the value n, and as one thing is there, see back in the question, it is mentioned that the show method will also call the DCOct function. Okay, show method will also call the DCOct function. So I'm going to call the DCOct function over here. So I'm going to write just DC underscore oct. Okay, and we are going to write the resultant variable which is the octal equivalent, and closed it. Now the next part we will write the public static void main, and here we will going to write the scanner class. System.in scanner is equal to new scanner system.in, and in the next line take any variable like int x equal to sc dot next int. Now we are just going to create the object. So they see opt. In this line there is no underscore is given. Ob equal to new dc oct. Now the methods to be called, as I said, only get num with the passing argument as x, which we have accepted from the user here, and The next procedure is to call ob.show. So ob.show also called, the main bracket is being closed and the class bracket is closed. Now let's look at to the dc-oct function, which is going to find the octal equivalent of it. Now to get the binary equivalent, we actually need to divide the number, keep on dividing the number by 2 until and unless I get a number which is lesser than 2. So similarly, the logic will come over here also. We will have to keep on chopping the number till I get some lesser value than 8. Okay. So until and unless, in the other way, if I say, we will keep on chopping if the number is greater than 8. That is my first condition. The second part of it is that whatever the quotient will come up, that quotient will again need to be get chopped up. But here my void dc-oct which is mentioned, it has no argument. So whatever the quotient we are getting, we cannot pass it as an argument. So we have to keep on storing it somewhere. So my original number, we will going to tend it to change it again and again. I am taking a local variable over here pointing as x1, and which will currently getting my whole original value. Okay, we will not going to write. I'm intentionally making it thing because generally I have seen that the boys do write while loop when it is mentioned clearly do in recursion. While or for, these are not for recursion. We generally do not write them. Instead of that, we write if function. Okay, if and else. So how long we will need to chop it till the value is greater than 8, right? So for that, we means that we'll keep on chopping it until the condition is that the value is greater than 8. Okay, now let's come inside this condition. What I'm going to do, I'm going to get the quotient. So my new number will be replaced by its quotient. So it will become n equal to n by 8, as it is going to be again changed. Once it is changed, my new number, if it is again more than 8, it need to be chopped up again. So I am calling the function, the recursive part over here, because as long as it is greater than 8, I'm keep on continuing calling this particular function again and again. So this is my recursive case. Recursive case. At this moment, how I need to form my number, which is the octal equivalent number. So for that, we write oct equal to oct, which is currently pointed as 0. Same as the way we do it in the reverse number, which is a palindrome reverse form. Oct into 10 plus, okay, there we did by tens, mod 10, sorry. So here it will be not 10, here it is going to be the 8, because my octal has an equivalent value of 8. So I'm going to write over here the value as x1, which is my temporary local variable we are using over here, x1 mod 8. That value is continuously will get stored over here one after another. Now let's see, once I finish writing my dc-oct recursion code, let me see what are the errors I can get over here. Currently I'm not getting any sort of error, so I'm just closing it and running the program with the void main. So I'm giving a value over here. Suppose I gave a value like 125, pressing enter. So 125 is the original number and the octal equivalent of it is 175. I can, in a similar way, I can check for the value. Another value we can give. Suppose I am giving 714. So the octal equivalent of 714 is going to be 1318. What you need to do is that divide 714 by 8, store the remainder separately, that is coming as an octal equivalent, but in a LIFO manner, and also the same way the quotient will become the next number to chop off. Okay, so by this we just finished one question related to the octal equivalent, which is a recursive form of question present in the ISC. Almost every year we will get this kind of question. Now let's close it and look at to the other recursive question that we can get. I'm choosing the almost next consecutive year, which is 2012. In this 2012, there was one example has been derived over here, which is related to 28. What it is doing is that they are chopping off the digit 2, making it square of it, adding it up as it got 68. Again, because it is a 2-digit number, it is again separating the digit 6 square plus 8 square. Again, it is adding up, coming as in the form of 100. Back again, 100 will be again 1 square plus 0 square plus 0 square, adding them up, coming into the back form of 1. Once it is coming as 1, at that time it is pointing at that it is a happy number. So basically they asked me to design a class and to find and check whether a number is a happy number or not. They have asked with a data member variable to store. Here somewhere the printing mistake is there, so it is n, which is denoted over here to store the number. Then a happy, which is a default constructor to assign 0 to n. Void get num to assign the parameter value to number n equal to nn. Int sum underscore sq underscore digit, which is not at all matched with my class name. Definitely earlier there was not a match but quite a similar base name, but here you can see it is actually mentioned as this is the function of recursive technique. Here it is int is mentioned, so that clearly stated me that I have to use a return statement over here, okay, to return my result. What I have to return? Return the sum of the square of the digits of the number 10, or number x, using the recursive technique. The x is which is passed as an argument over here in this question in the method sum underscore sq underscore digit. Next one is void happy, which is to check if the given number is a happy number by calling the function sum underscore sq underscore digit end. See again, like the previous question where it was mentioned that the recursive part is being called inside the void show. Similarly over here also, is happy is a method which is displaying the result with an appropriate message, along with it is calling the recursive function. So let's start with this part. As we know that the class name will going to be happy. Just opening it, clearing out everything. Let's start with import java.util.star. The same procedure I will follow over here. I will write everything else first. Class happy. And private data member variable, which is only int n mentioned over here. nothing else. Then I have over here a default constructor, so I'm going to write public happy pointing as n equal to 0, closing it. Again, a method is mentioned as void get num with the parameter int nn. So pressing enter over here and then initializing that in my private variable. Next, just I'm going to write the function definition over here, which is int sum underscore sq underscore digits and in the bracket int x. Please, for your benefit, always go through the question, check that properly, what you are writing, the class name, the method, that argument, everything needs to be exact, correct, whatever is mentioned. I'm opening and closing it, not doing anything. Coming to the next part of it, which is void is happy. And we will do the void is happy part first. Now, here void is happy part needs a little bit technique over here. Why I'm saying that? Because in this question, generally, if through a while loop, it has been asked us to do the work of a happy number. We are going to use two while loops over here. One while loop is basic to chop up the number. Another while loop is to again chop up the number if the number is a 2-digit number. It will continue, keep on chopping off. So both of the while loop to put in a recursion will be difficult. So what I'm going to do is that I'm going to put a certain section in the inner for loop into the recursive part, and the basic outer for loop is in the is happy part. So for that, I am taking some variables, local variables, initializing as int a as equal to 0, and also I'm taking a variable num which I'm also initializing as 0. Now I'm calling the function previous one as it mentioned that call the recursive function over here. So a is going to store the result for me, which is from the original private data member variable. If whatever I'm getting as a, that is a 2-digit number, which is mean it is more than the value 9, we need to send it back again to the recursion function. So I'm going to write num equal to sum underscore sq underscore digits, and then pass again the value a into it, and replacing my a with the result value, that is num. Okay, we are doing it, we are calling it twice because we are not sure whatever the result we are getting through a is a 2-digit value or a single digit value. If it would have been a single digit value, we don't need to bother about anything else, but if it is not, we need to send it back. So at the end we can check if num is going to point it as 1. I'm simply going to write system dot out dot println, it's a happy number, else system dot out dot println, it's not a happy number, and I'm going to close this happy number section. Now over here I have to write the public static void main. Say let's write that part first. Let's open it. Write the scanner class statement. Scanner is equal to new scanner as system.in. We can just write a statement also that enter the number, which I have not written in the previous one. And we are going to take in any variable, suppose x1 as next int. Okay, we have to clear make an object of the class. So we are going to make happy ob equal to new happy, and then call the method first the get num. So ob dot get num with the value x1 that we have taken from the user, and then ob dot is happy, this method, and then close it off. Now we are still left to write the recursion part. As the recursion part is doing what? It is making the square of the number that is present in the question. Each and every digit is being extracted, their square is being found, and after that it is actually whatever the digit chop number is there, the square form of it is being added to its next or one of it. So the same way we are going to do it step by step. So first we need to see that whether it is a single digit number or not. So we are going to write not with while anymore. We are using while because it is a void is happy. It is not a recursive method. In the recursive method, we are not going to use while. We are not going to use for. Okay. We are going to use if else statement. So I'm going to write first my general statement, which is if I find that the value which is argumented as x, so I cannot use any other variable, I have to use x only. So I'm writing if x is greater than equal to 0, because one digit number can be also 0, or x is actually lesser than equal to 9, then at this point we are just going to return, because it is having the data type as int, so we must write return. So we will write return x into x, because that will give me the square form of it. If it is more than one digit number, then we need to chop it off. So to chop it off, we will first write return, and then the chop it off digit again need to be sent back. So we are going to call the function sum sq underscore digits. First chop it off, we are going to chop it, we know that, through x mod 10, and then after that the same value will be added with the next part of it. So again sum underscore sq underscore digits. The next section of it we will get by x by 10, which is the quotient section. So just close it off and give a semicolon at the end. After finishing it off, let's look at to the errors that we are going to get. Here the S system S is going to be capital, and I'm going to compile it. Print ln, okay, so it is print and ln. Okay, so there is no syntax error, so I'm closing it off and checking for the happy number. with the void main. It is asking me for enter a number. Let's first not give any happy number. I'm giving only 12, which was as per in my question present, and it said that it is not a happy number. So I gave 12, which is pointing as not a happy number. And then let's try back again with a happy number, which is 28. So let's try back with the value 28. When I'm writing 28, it is pointing it's a happy number. So successfully we have did both of the recursion program. Now I'm going to send you one recursion based worksheet program, which will be again as of your homework. Please try it by yourself. Try to write the recursive format of it. Only trial and error method will try to make us perfect. Lasmer boys, thank you for watching this video. Please stay safe, stay at home. The worksheet will come to you very soon through a PDF material. Please do the work. Get back to us with any queries. Stay at home, stay well. Thank you very much.